Hello, and I hope you are doing well. Today I did a model of the large scale explosion, something like nuclear bomb. You know, the nuclear bomb uh, has two components. First component is the detonation wave pressure, and the second, or shock wave, and the second is the temperature. Here we consider the shock wave here for the uh, a bomb, a typical nuclear bomb. Here you can see that here. This is the nuclear bomb. Here it is around 1 kilometer. This is a building with 100 as elevation, and if I click and animate, you can see this explosion. Let me make this like that. See the explosion. It is the huge amount of pressure, of energy, which destroyed the building with 5 meter thickness at a glimpse of eye. It means that detonation pressure is too much, the speed wave, everything, because this is something like nuclear. See, it is also like a mushroom. See here, it is something like mushroom. Let me again click on this. See, it is 5 meter thickness concrete. It is failed completely. And this is the gross, and this is the final view. See, it is about 1 kilometer the length, 150 millisecond or 0.15 second. It travel around 1 kilometer, under the 1 second, and that's the huge velocity. We can check it velocity here. See, the velocity is 2000 meter per second, 2000 meter per second maximum, but it is too much also. Here is the average, average velocity. So if we got the TNT, the nuclear bomb as the volume fraction, and we can make it this view. See, this is the bomb propagations. See the penetration of the wave inside the soil. Here is soil, here is air. The soil has 50 meter thickness here, 50 meter, and this depth and this crater is about here maybe is about 30 meter. The crater is 30 meter, which is created by the nuclear explosion. Here you can see the volume fraction for air, volume fraction for soil. Here, see, this is the crater. It is about 25 to 30 meter. We can use also this here, the penetration of the wave inside the soil. This is the penetration. See, it is the crater. If someone be in the underground shelter, that would be again destroyed, the underground, because it is 30 meter penetration inside the typical soil. We can use also this as the view. You can see that here. This is the view, and we can check also the compression damage. For instance, for building, this is the concrete building. It is failed completely. See the compression damage here, the compression damage. The thickness of the building is 5 meter and the elevation is 100 meter, but you can see it doesn't have any resistance against the nuclear pressure load. Why? Because that's too much. If we make a city here, all the buildings will be destroyed. Okay, so we use some technical to model this in the CEL method, and concrete damage plasticity also. And if you need to model this detonation, this explosion method, you can come to our website here, www.abaqusfm.com. Find the English tutorial here, click on the title, then you will have the title and then the part definition, geometry here, as step interaction load, and the result as figures. The cost for the CAINP English video file or transport material is €30. You can use a PayPal account. This is the best way, or a Visa or MasterCard for the payment. Before that, send me an email to this address. Also, you can provide our full package here. The full package contains all our tutorials, around 400 cases about anything. For instance, the explosion with all method impact for any material, low and high velocity, welding, biomechanics, forming, cracks, soil, CFD, FSI, thermal, anything. You can find anything here. And the cost for the student especially is so affordable, also for engineer or teachers. If you need also this full package with more than 400 tutorials, contact me to this email. Thank you for your attention.